Alright, I've got a complex fraction problem here to simplify, and I get asked this question a lot in class. Poyser, how do we simplify things like this? Well, there are two methods. The book that we use points out two methods to solve or to simplify complex fractions. And again, complex fractions, if you're wondering what does that mean, it just means that there are fractions inside of fractions. That's what makes them complex. Well, the first method I'm going to show you, what I guess the book calls method 1, is to tackle these two fractions. And when I say two fractions, I mean these two up top and these two on the bottom separately. So I'm just going to cover up for a quick second here. I'm just going to cover up these two on the bottom and ignore them for a moment. And I'm just going to concentrate on what's happening in the numerator. Alright, so what I'm going to do is I'm going to add these two fractions. That's what they want us to do. They want us to add these two fractions. And to do that, I first need an LCD, which in this case is going to be 5y. So it's actually the product of both of these. Alright, so this fraction, if I want its denominator to look like 5y, I have to multiply it by y. Well, if I do that to the bottom, I must also do it to the top, to its numerator. So my numerator now is just y. Here's my plus sign being carried over. And this denominator, if I want it to look like 5y, is missing a 5. So I'm going to multiply its denominator by 5. Have to multiply its numerator by 5 as well. So my new numerator over here is 15. So there, I just added those two fractions together for the two numerator fractions. But I have to do the same thing on the bottom as well. This is still the method, what the book calls method 1. I need to, if I'm going to add these two together, I need an LCD. In this case, it's going to be 7y, and I hope you see adding or subtracting fractions, same thing. I need that LCD of 7y. So I need to multiply its denominator by y to make it look like that. And if I do it to the bottom, I have to do it to the top as well. So my new numerator over here is just a y. Let's see, this denominator is missing a 7 to make it look like that. So if I multiply its denominator by 7, I've got to multiply its numerator by 7, which gives me a 63. And see that minus sign right there? I'm just going to put that in between those two terms. So now I've got it down to a form where I've got fraction up top divided by, that's what this big fraction bar here means, simply divided by fraction on the bottom. And if I want, I can rewrite those two. I can rewrite them as y plus 15 all over 5y divided by this denominator here. But instead of saying divided by and then writing this, why don't I just change it straight to multiplication and flip that bottom fraction? Okay, so I'm going to flip this one over here and write the 7y up top and the y minus 63 on the bottom. So I kind of skipped a couple of steps and put them together in one. Okay, to finish off this problem and to clean it up a little bit, I'm going to do one more thing. I'm going to take these y's here, this single y and that single y, and they cross each other out. But I cannot cross these y's out. I kind of think of these y's as married with kids. They've got a bunch of other things going on. They're attached to these other things. Whereas all of this was multiplication. That's what allows me to cross these guys out. Division is the opposite of multiplication. Alright, so my final answer then here is, if I clean up the numerator, I've got a 7 times y plus 15 in my numerator, and on the denominator, I've got a 5 and a y minus 63. Okay, so that's as far as I can go. I can't cross anything out. These two parentheses are not the same, and that is my final answer. Now, if I wanted to, I could solve or simplify this exact same problem using a slightly different method. There's another method that the book points out, and it's called method 2, or find the LCD first and multiply all four terms by that. So I'm going to show you this exact same problem that we started with using a slightly different method. I actually like this method better because it goes a lot faster. You'll see that I'm going to jump straight to my answer here in no time at all. Okay, so the first step in method number 2, call it method 2, is to first find an LCD. But this one here, this LCD that I'm looking for, is the LCD of all four of these fractions. Do you see that there are four fractions, and I need to find the LCD for all four of these fractions? So out of 5 and y and 7 and y, I hope you see that the LCD is 35y. That's my LCD. So what I'm going to do is I'm going to multiply every one of these fractions by that LCD of 35y. So even these guys over here get multiplied by the LCD. And in doing so, watch, I'm going to be able to jump straight to the answer. This is pretty cool. Okay, so let's tackle this one here in the upper left. Let's see, does anything simplify? Does anything cancel out when I multiply these two? Oh yeah, look, 5 goes into 35 7 times. And I'm left with 7 times this y times that 1. So I'm left with 7y for this box that I just kind of put in the box. All this stuff shrinks down to just a 7y. Alright, here's my plus sign in between. Just going to bring that on down. And I hope you see when I multiply these things over here, this stuff, that the y's are going to cancel. And I'm left with 3 times 35. Well, we know that 3 times 35 is simply just a 105. So I can just write it like that, 105. Okay, 3 times 35. That's all I did. Okay, same thing down here, same thing over here. Let me do this one first. Let's see, 7 goes into 35 5 times. And I'm left with 5y times 1. So my denominator's first term is a 5y. Bring on that minus sign down. The y's cancel out here. And I'm left with 9 times 35. Okay, that's a bigger number, but 9 times 35 is simply 315. Okay, so this is my, believe it or not, final answer. That's as simple as I can make it. So it's kind of neat that it jumps straight to the final answer. Now you're probably wondering, hey, wait a second, that wasn't the answer you had before. Well, it actually is. If you take 7 and distribute it into both of these two terms, you'll see that you'll have 7y, and 7 times 15 gets you to 105. And if you distribute this 5 times both of these terms inside here, you'll see that you'll have 5y minus 315. So it actually does come out to be exactly the same. And if you were doing this on my math lab, it would take either one of these two answers. They're both correct. Same answer. Hope that helps.